The mathematics. Today we are still on the 2024 University of Florida Integration B qualifying round, part 3, problem number 25, which is a definite integral from x equals 0 to x infinity of the arctangent of 2x over x squared plus 1 over x. So this is a quite interesting problem, but let's see how we may be able to solve it. Before we go into the solution phase of our problem, I would like to encourage those of us who haven't subscribed, please do consider subscribing to our channel. Your support will go a long way in helping us increase the profile of our channel. If you like what you see, please leave a like. And if you do know anybody who might benefit from what we're doing, please do share our channel with them. So without much ado, let's proceed into the solution phase of this problem. Is this definite integral from x equals to 0 to infinity of the arctangent of 2x over x squared plus 1 over x. The first thing I personally would like to do is to say let x be equal to tangent of theta. And what does that mean? It means that dx d theta is equals to sec squared theta. And so we can substitute for dx with sec squared theta d theta. Now, when x tends to 0, what does that mean? It means that theta tends to the arctangent of that, which is theta tends to 0. When x tends to infinity, theta tends to pi over 2. And so our problem to x over x squared plus 1 over x would be equal to 0 to pi over 2 of 2 tan theta over tan squared theta plus 1 over tan theta times sec squared theta. Okay, so this is interesting. We know that tan squared theta plus 1 is equivalent to sec squared theta. Therefore, 0 to pi over 2 arctangent of 2 tan theta over tan squared theta plus 1 over tan theta tan sec squared theta is equals to 0 to pi over 2 arctangent of 2 tan theta over sec squared theta over tan theta times sec squared theta. So what we have here is two sine theta over cosine theta divided by, so this is the same as times cosine squared theta over 1. we have 1 sine theta over cosine theta times 1 over cosine squared theta. Okay. So this and that, and that. So we have 2 sine theta cosine theta over sine theta cosine theta. So 2 sine theta cosine theta is the same as sine 2 theta. So we have sine 2 theta over sine 2 theta times 2. Okay. So this means that we have twice 0 to pi over 2 arc tan sine 2 theta over sine 2 theta. Okay, so that's interesting. Now we could even just substitute and say let u be equal to sine 2 theta. So if we say let u be equal to 2 theta, that means that du d theta is equals to 2, and that means that du over 2 is equals to d theta. Okay, and then what that means is that when theta equals to 0, u equals to 0. When theta equals to pi over 2, u is equals to pi. In other words, so 0 to pi over 2, twice of that, arctangent sine 2 theta over sine 2 theta. That's the same as 0 to pi twice arctan sine of u over sine of u, and then we have du over 2. Okay, so that and that cancel. Equal to the integral from u equals to 0 to pi arctangent of sine of u over sine of u, and we can split it into two integrals. Integral from u equals 0 to pi over 2 of the arctangent of sine of u over sine of u, like that, plus pi over 2 to pi arctangent of sine of u over sine of u. Let's focus on this, and let me probably use blue just to highlight that integral. So if we say let w be equal to u minus pi, right? That means that dw is equals to du, and so when u equals to pi over 2, that means that w is equals to negative pi over 2. When u equals to pi, that means that w is equals to 0. So that means that the integral from pi over 2 to pi of the arctangent of sine of u over sine of u is equals to the integral in the w domain from w equals to pi over 2 to 0 of the arctangent of sine of w plus pi over sine of w plus pi, which is equals to 0 arctangent. Sine w, this is same as negative sine of that, because we have sine w cosine pi plus sine pi cosine pi. So cosine pi is -1, and that is that. So we have negative that. And this negative propagates out, and they cancel with that. And so to have negative pi over 2, 0 arctan of sine of w over sine w. And one thing we could do is apply negative to the w, and so let's say which means that of vice versa, and so that means is equals to pi over 2, because it's a negative here, 0 arctan of sine of right, and negative. You see, this propagates out, and this and that cancel, but we have this one here that causes the sign to flip. So we have over, and therefore what essentially we have is that our original integral 0 to pi arctangent of sine of u over sine of u is the same as twice arctangent of sine of u over sine of u. Okay, so we're going to use a technique called differentiation under the integral sign. The other, we also know it as the Feynman's technique. And how do? We say, okay, let IA be equal to twice the integral from 0 to pi over 2 arctangent of A sine of u over sine of u. And then what we say, okay, the derivative is the same as twice partial derivative of the arctangent of A sine u over sine u. What does that equate to? So if we say it's the same as twice, 0 pi over 2 sine over u over sine of u, 1 over 1 plus a squared sine squared u. So that cancels, so we have 2, 0, pi over 2, 1 over 1 plus a squared sine squared u. And since we know that cosine squared u plus sine squared u is equivalent to 1 using that. So therefore, we say I prime of a is equals to twice 0 to pi over 2, 1 over cosine squared u plus sine squared of u plus a squared sine squared of u. Okay, so we have 0 pi over 2, 1 over cosine squared of u, 1 plus a squared sine squared of u. Now if we divide both the numerator and denominator by cosine squared u, we have 2 pi and we have sec u over 1 plus a squared tan squared u du. So we could, since we have that to be equal to 0 to pi over 2, and we have twice of that, sec squared of u over 1 plus a squared tan squared of u, we could say let's see y be equal to the square root of 1 plus a squared tangent of u, such that dy du is equal to square root of 1 plus a squared sec squared of u, and so dy is equal to 1 plus a squared sec squared of u du. Okay, and limit when when u equals to 0, y should be equal to 0. When y, or when u equals to pi over 2, y should be equal or should tend to infinity. Right? So now twice 0 to pi over 2 sec squared u 1 plus a squared tan squared u du is equal to twice 0 infinity, and sec squared u is the same as this is a 1 over 1 plus y squared, this here, and then we have dy over square root of 1 plus a squared. Okay, so this is the same as twice square root of 1 plus a squared, 0 infinity 1 over 1 plus y squared dy. So we have twice square root of 1 plus a squared arctangent of y 0 infinity, which is 2 1 plus a squared I over 2 minus 0. So we have twice over 1 plus a squared times pi over 2, which is equals to pi over square root of 1 plus a squared. So since is equals to that, IA is going to be equal to pi okay, and since IA is equals to pi, the integral from it's an indefinite integral of 1 over square root of 1 plus a squared. We'd say let a be equal to tangent of theta, dA d theta is equals to sec theta, and therefore dA is equals to right? And so IA will be equal to, let's use theta for now because we have 1 over square root of 1 plus tangent of square theta, or square theta d theta, which is pi. This is sec square theta, so we have sec square theta over sec theta, which is equals to pi integral of sec theta. And that means that I for theta is equals to pi sec theta integrated, which is pi natural logarithm of sec theta plus tangent of theta plus c. Since we said a is equals to tangent of theta, what does that mean? It means that sec theta will be equal to square root of 1 plus a squared. So in other words, is equals to pi natural logarithm of square root of 1 plus a squared plus a plus c. Now, since we said IA is equal to the integral twice the integral from 0 to pi over 2 of the arctangent of twice sine of u, a over sine of u, we see that our I1 is equals to the integral that we are interested in, which is that. But however, I of 0 is equals to 0. So therefore, I of 0, which is going to be equal to pi natural logarithm of 1 plus 0 is 1 plus 0 plus c, and this is 1, so this goes to 0. So in other words, c is equals to 0. And therefore, since c is equals to 0, then IA is equals to pi natural logarithm of the square root of 1 plus a squared plus a. And since our integral of interest is I of 1, so that's the same as pi log of square root of 2 plus 1. Therefore, our original integral that was very interesting for us which is the integral from 0 to infinity of the arctangent of 2x over x squared plus 1 over x is equals to pi natural logarithm of square root of 2 plus 1. And that is our answer. So that's super interesting. I hope you did enjoy it. If you have any questions, we do welcome any questions from you. Until next time, bye bye.